Okay, welcome everybody today. Today is section 5.5. We're going to talk today about a new topic, which is the negative exponents and scientific notation. We have studied before about positive exponents. So how about that? What if I have x power of negative 5? What am I supposed to do with that? I got stuck with that, so it's something new for me. But hey, how can I get that? If I say, like, this is x power of 2 divided by x power of 5, what should I get here? As I knew before that this is x power 2 minus the power of the denominator, which is 5. So that would be x power of negative 3. The same thing that I don't know what to do with that. Okay, let me work on that in another way. I could analyze that one. This is x times x divided by x power of 5x times x times x times x times x. X with x is cancelled out, x with x is cancelled out, equals 1 equal over x power of 3. So that guy is equal this one. So that means if x power of negative 3 equals 1 over x power of 3. So let me go to the rule here. If a power of negative n equals 1 over a power of n. Okay, that would be more clear by example. So let's take some examples about that. Two x power of negative 4. I have a negative here. So the first thing I do is to move that guy down. So 2, I will keep 2 here and down. I'll put x power of 4. One more example. 2 power of negative 5. Get the reciprocal, 1 over 2 power of 5. And what 2 power of 5? That's 32. So that's my answer. One more example. Let's say 2 power of x of negative 2, y of negative 5. That would equal what? Let's go back to the rule. When it's negative, it goes down. So I will keep 2 and go down to the denominator. Oh, this is negative 2, so this is x power of 2. This is y power of negative 5, so that would be y power of 5. And this is the answer. So now the first rule is if a power of negative n, that would equal 1 over a power of n. Okay. What if I have something like that, 1 over x power of negative 5. I know that x power of negative 5 equals 1 over x power of 5. So what about that? Actually, it's the same thing. Let's suppose to say this is x power of negative 2 divided by x power of negative 5. What should I get here? That would be x power of negative 2, negative 5. That would give me what? Negative 2, x power of negative 2 plus 5. That would be x power of 3. So that means that if the exponent is negative and it's in the denominator, it goes up again to the numerator. To make this example better, let me make this 7. And this is 7. This is 7. So that would be 5. So here, 1 over x power of negative 5 equals x power of 5. Now I can set my rule. My rule would be if 1 over a power of negative n equals a power of n. Okay, so let me make an example. Take an example for that. 1 over 10 of negative 2. Take it up. So that would be 10 power of what? Power of 2. And what's 10 power of 2? It's 10 squared, which is 100. Okay. 4 power of negative 3. 3 power of negative 4. So here is example 2. 4 power of negative 3 divided by 3 power of negative 4. How could I solve that? Okay, let's take this. I'm going to make the line between the numerator and the denominator and take each part. 4 power of negative 3 equals what? Equals, I'm going to get 4 down with the negative power. So that would be 4 here with a power. Okay, I'm done with that. What about that guy? This is 3 power of negative 4. Okay, in the denominator. So I have to make it up with the positive exponents. So that would be 3 power of 4. Okay. 3 power of 4 is 3 times 3 times 3 times 3 is 81. Divided by 4 cubed is 64. And that's another example. So let's take a different kind of examples about that. How about this? 2 divided by 3 power of negative 3. I would love to solve this in 2 different ways. The first way is to distribute the exponent. The second way is to flip it over. First way, distribute the power. So that would be 2 power of negative 3 over 3 power of negative 3. That's easy. And the second step is the same way as the previous example. So that would be 3 over 3 over 2 over 3, which is 27 over 8. The second one says that, okay, you distribute first and then change the power. So I'm going to change or flip it over first. I make it 3 over 2, power of 3, and then distribute the power. That would give me 27 over 8. 2 steps. I can start whichever you want. So, with this example, I think that we would be covered the first part of this section, the negative exponent. Okay, let's go to the second part of this section. We're talking about the scientific notation. Well, some people started to think about that. Oh, we have a very big numbers or very small numbers. Like, if we say that the distance between the Sun and Pluto is 6, you remember it's 5,906,111,000 kilometers. Uh-oh, that's really a big number. Is it easy to write that down like that? I don't think so. The mass of the proton, if that easy way, if that could be writable, the mass of the proton is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 164 gram. How about that? It's crazy, huh? So, this stuff, it's usually used in science. So that's why we call them scientific notation. So, for sure there is a way to take care of that in a reasonable way. So, this way that we are talking about today, it has that form. A times 10 power of R. This is the scientific notation. Okay, we have a condition for A. A is supposed to be greater than 1 and less than 10. So it's greater than 1 and less than 10. What about R? I have two conditions for that one. If that number is less than 1, if the number, standard number, is less than 1, R is negative. If the standard number is greater than 1, R is positive. Is that clear? Cool. So, to convert from a big number or a standard number to scientific number, there's 3 steps to do that. Let's get a number or one of those crazy numbers and convert them to scientific one, or put them in the scientific notation. So let's get, how about that? 367, 111, zeros, 6 zeros, 9 zeros. Okay, step 1. Make A between 1 and 10. So this number is supposed to be, I will move the decimal. This is supposed to be like that. I'll move that decimal to be here, to be 3, between 1 and 10. Okay, while doing that, I'm counting how many decimal I am moving. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. So those are 11. So my number is here 367. And what's count I did? That's 11. Okay. The second thing, this is a step 1. The second step is this number is a fraction or less than 1 or more than 1. Actually, I see it, it's more than 1. It's 367, 0, 0, 0, 0, 0. It's obviously more than 1. So 11 would be positive. And then let's multiply by 10 times 11, positive 11. That's it. I know, that's a new way, so let's make it more obvious by another example. How about that? Again, let's move the decimal and make this only between 1 and 10. So that would be 3.5. So I will move it 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Write it down. 6. Positive or negative? Oh, that's positive. So what should I do here? I'll write that number down, 3.56. I don't care about zeros, by the way. Times. What did I do here? 10. Is it positive or negative? That's positive. So make that the exponent of 10. And again, this is a number. So now we've talked about numbers is over 1. How about fractions? Let's take an example for a fraction. Another example, and this example is a fraction this time, or a decimal, which means that the exponent would be what? Would be negative this time. Okay, I will move the decimal point to make this from 1 to 10 as we agreed before. So I'll move it 1, 2, 3, 4. Oh, that's 1 over 1 here. So I'll move it 4. So what would I get here? Oh, 125 times 10. 1, 2, 3, 4. 4. Is that correct? No. This is a negative this time. Put here the negative. This is the difference. If I see the negative as a power of 10, it means that this number is a decimal or a fraction. If I see this number as positive, it means that this is a big number and it's over 1. My last example today is about the scientific notation is how to do operations about scientific notations. So let's do something so quick about that. How about that example? 8 times 10 power of negative 6. That times 7 times 10 power of 3. First of all, I need to understand those two numbers. Are those standard numbers? No. Are those scientific notation numbers? Yes. Okay. Is that a big number or a small number? Look at this. This is negative, so it means that it's a small number. And what about this? This is a big number because it's positive. Okay. This is the first thing. The second thing is, how could I multiply that? First thing, I have to multiply. Let's call that A, and that's A. I need to multiply A together. So let's say that, call this A1, and this is A2. So 8 times 7 is 56 times what? Let's multiply this. When I multiply 10 times negative 6 times 10, 3. As we have learned before, when we multiply same base with different exponent, we add the exponent. So let's simplify that. 56 times 10, negative 6 plus 3 is, yes, negative 3. Thank you. All right. But I remember that this doesn't work for the notation. It's supposed to be from 1 to 10. 56 is not from 1 to 10. How could I make that from 1 to 10? I have to move the decimal 1 there. So when I move that, I have to add 1 positive or negative. Positive or negative? Oh, someone would say negative. This is a negative. Is that correct? No. This 56, I'm moving it to the right, to the left, which means that I am reducing it. It means that I'm dividing by 10, so I have to add 10, which means that I have to add 1 here. So that would be 5.6 plus 10, times 10, negative 3 plus 1, which means that 55.6 times 10 power of negative 2. Last thing, can we put that back in the standard form? Yes. 5.6 times, what is that number? If we remember what we got from the negative exponent, when we have a negative exponent here, we flip it over, so that would be 1 over 10 squared. That would be 5.6 times 1 over 100. That would equal 0.056. And that's it. And thank you so much. By this, we are done with section 5.5.